Okay, so question 12 of KA4 for maths. We've got this cylinder, radius r, height h, given the volume is 400, show the area is this. Now, general advice for these kinds of questions is parts A are often a bit awkward. Students normally struggle a bit with it. B, C and D are really standard. That is, find it, and it's almost always this pattern. Find the r value or x coordinate of a stationary point. Prove it's a stationary point that you need, minimum or maximum. And then find the actual value. Sub it back in to get the y coordinate. So it's find the coordinates of a stationary point and determine the nature. That is parts B, C and D summarised. So part A, we've been told the volume, so let's find a little equation for that first. So V is pi r squared h. So 400 is pi r squared h. Now, surface area. So we've got a lid and a base. So we're going to have two lots of pi r squared, two of those circle areas. And then around the outside, we've got these curved surface area of a cylinder, which if we imagine unrolling it, it's going to have this as its kind of length. If we unfurled that, that would be the length, the circumference. Let's do it at the top. And then the height. Now the circumference of a circle, get rid of that, sorry, is 2 pi r. So it's 2 pi r h. Now, the thing that's in our equation that's not in theirs is h. There's no h in there, so we need to get rid of it. Now we can rearrange this one to be 400 over pi r squared. So we get area is 2 pi r squared plus 2 pi r, 400 over pi r squared. And the answer falls out a lot. The pi's cancel, one of the r's cancels, the 2 times 400 becomes an 8, and we're left with an r on the bottom, and we're done. So, part B, find the exact radius of the can for which A is a minimum. So, first thing, I'm going to rewrite A so we can differentiate it. And then let's do that. So 4 pi r minus 800 r to the minus 2. Now we need to find where that equals 0. My first thing to always do with negative powers of the unknown is we make it a fraction. Now we can divide by 4. So we have pi r minus 200 over r squared. Times up by r squared, so 2 pi r cubed minus 200. So r cubed is going to be 200 over pi, and r is then the cube root of 200 over pi, and that is indeed exact. Okay. How much space have I got? Plenty. Part C. By finding d2a by dr squared, show the radius is a minimum. Now this should be screaming for everyone to get 3 marks minimum on this question. That bit is telling us we at least need to differentiate twice. And you're told the original thing. So 3 marks minimum for most people on this question. So let's start by differentiating again. So d2a by dr squared. So we've got 4 pi plus 1600 r to the minus 3. Sub in the r value, d2a by dr squared, 4 pi plus 1600, cube root 200 over pi to the minus 3, which will come out to be 4 pi plus 1600 over pi . 12 pi actually, which is quite nice, which is more than 0, Therefore, r equals cube root of 200 over pi is a min. Well, let's word it the way they might want. It gives a min value of a. Okay. Part D. Calculate the minimum value of a. So that is just subbing that back into the original. So it was 2 pi r squared, 2 pi r squared minus 800 plus 800 minus 800 plus 800 over r, which will come out to be, let's make that and save ourselves a little bit of time, 2 pi ands squared plus 800 over ands 300.5. Did it say it wanted a specific? Approximately 301. Cool. So that is question 12.